Greetings Year 11/12 students. Today we're going to be looking at exercise 3B. We're going to be looking at asymptotes, both vertical and horizontal. Now, just a quick overview of what the process is going to involve. When we're looking for vertical asymptotes, when we look at the question, we're going to have to factorize it. If there is a fraction, look at the bottom of the fraction and set it equal to 0 and solve it. Whatever x equals, that is an asymptote, providing that same answer doesn't come from the numerator, which we'll talk about another time. We're going to draw a table of signs and have a look at what's happening either side of the asymptote so we can understand where our graph is heading. For horizontal asymptotes, factorize, which we've already done because we did that for the vertical. We're going to divide the top and the bottom of the fraction by the highest power of x in the denominator. That'll become obvious when we do an example. Then we're going to use the fact that 1 over a large number is 0 when x approaches infinity or minus infinity. 1 over a very large positive number or 1 over a very large negative number gets close to 0. And we're going to be able to use that to help find out what's happening around the horizontal asymptotes. So let's get straight into it. Here's our first example. So the first one says to consider our graph y equals -2 over x take 4. Let's write down the domain using both interval notations. Now, the domain can be found by looking at the denominator, noticing that x cannot equal 4, it can be anything else, so the domain is x cannot equal 4, or if we're using interval notation, a different way to write it, we would say x goes from minus infinity through to 4, but it doesn't include 4, or from 4 through to infinity, not including 4. Now let's see whether the function's odd or even or neither. Now remember, to test whether something's odd or even, we replace all of the x's with minus x's. So it becomes -2 on minus x take 4. Now that does not equal f of x. That's not the same as the original, and it certainly doesn't equal minus f of x, which means it's not odd, it's not even, it's neither odd nor even. Next question says to find any zeros. Zeros come from setting the numerator to 0, setting the denominator to 0. Discontinuities come from the denominator, zeros come from the numerator, and then we'll construct a sign diagram. So there's nothing on the top of this fraction here that's got x's in it, so there's nothing from the top to sign. It's just the bottom. X equals 4, so is what you solve that to. B, for example, if you look at the denominator and write it down, make it equal to 0, plus 4 to both sides, solving the denominator gives an answer of x equals 4. So what we're going to do is we're going to create a sign diagram or a sign table using that information. So on our sign table, we've got an x value, we've got a y value, and we've got our sign. Now, the x value that we're interested in is 4, and we need a number either side of 4. Why is it 4? Because that's what I found up here. So pick a number to the left of 4, I might pick 3. Pick a number to the right of 4, I'll pick 5. If I plug 4 back into the original question, I get 4 divided by 4, I get a 0 on the bottom. You can't have a 0 on the bottom, so there is no y value. I'm just going to put an asterisk there to say that there isn't anything. That doesn't make sense. But if I put 3 into the question, 3 take 4 is -1. -2 on -1 gives 2. Which is positive. The sign is positive. If I now plug 5 into the question, 5 take 4 is 1, -2 on 1 gives -2, which is negative. So that's my sign diagram. I'm interested in this row here in particular. This is saying to the left of my asymptote, my graph is above the x-axis, they're all positive. To the right of the asymptote, my graph is below the x-axis because the graph will be negative. Now let's find the vertical asymptote. Well, the vertical asymptote comes from setting the denominator equal to 0, so I know it's at x equals 4. We've already looked at that. But the next part says describe the behavior near it. So what we do is we say this. as x approaches 4 from the left side and as x approaches 4 from the right side. What happens to y in each case? Now, what we're going to do, actually I might even go back, I'll get rid of those y parts. I'll say, as x approaches 4 from the left, y is going to be very close to negative 2 over, now up here, when I look at the question, I want to pick a number that's not 4, it's a little bit to the left. Minus means to the left of 4. A number to the left of the 4 on the number line could be something like, and you can pick any number, left of 4, but you want it close. I might pick 3.999. And if I put that into my calculator, I get an answer of 2000, which means y is approaching a very large positive number. When I look at this case here, when x is approaching 4, where the little plus means to the right of 4, I'd say y is approaching negative 2 on something close to 4, but it's on the right of it. If I put that into my calculator, that's going to end up equaling minus 2000, which means it's approaching a large negative number. Now let's find the horizontal asymptote. Now this is a tricky part. We look at the original question, here it is, and we're looking in the denominator for the highest power of x, which is there. So what we're doing is we're rewriting the question. Minus 2 over x over x over x minus 4 over x. That's what we get. Everything gets divided by x. Why x? Because that was the highest power of x in the denominator. Now, we also know that if x is a large number, 2 over a really big number is close to 0. So it's going to be minus 0 over x is 1. That's x over x. 4 over x, 4 over a very large number is 0. Minus 0 over anything is just 0. So, what's my horizontal asymptote? My horizontal asymptote is y equals 0. But what I need to do is I need to describe the behavior near my asymptote. So what we do is we say, as x approaches infinity, y is approaching. So I'm going to go back up to the original question and I'm going to put in a number that's approaching infinity. In other words, I'm just going to put in a big number to see what's happening if I put a big number in. So it might be something like this. Minus 2 over a big number. I might try 999. That's a big number. Minus 4. And if I put that into my calculator, I end up getting minus 0.002, which is very close to 0, but it's a little bit to the left of it. And as x approaches a large negative number, means I'm going to put in a big number that's negative. Put that into my calculator, and that answer will approach 0.002, which means it's approaching 0, but it's positive. Now let's sketch the curve. Here's my sketch. Well, first thing I need to do is put my asymptotes in. I know there's an asymptote at 4. So there's a vertical asymptote at x equals 4. Now, what else do I know? I know that for this particular graph, I know that there is also a horizontal asymptote. Oh, so I need to put my horizontal asymptote. The horizontal asymptote is 0. So there's a horizontal asymptote, which is the line y equals 0. Now this is where I need to study what's going on. I said when well, let's look at minus infinity. As x approaches minus infinity, y is approaching 0 from above. So let's put our graph in. So x is approaching minus infinity. So if x is heading to the left, that's where minus infinity is. The graph is approaching a y value of 0 from above. As x approaches my asymptote on the left, that's as x approaches 4 from the left, y is approaching infinity. So it goes like this. As I get closer to my x equals 4 asymptote, y approaches infinity. As x is approaching 4 on the right of it, y is approaching a large negative number. So it must be down here. And as x approaches plus infinity, y is approaching 0 from underneath. So there's my graph. There's one more thing I could show. I notice there's a y-intercept. How do you find a y-intercept? Let x equal 0. If I let x equal 0, negative 2 over negative 4 becomes plus a half. So it crosses the y-axis at half. And there's my graph. Let's go on to the next one. So, question number 2. Question number 2 says to look at the horizontal asymptote first. Well, to find a horizontal asymptote, I have to look at the denominator. There's an x and a minus 3. The highest power of x is x to the power of 1. So every term is going to be divided by x to the power of 1. So I get y equals x over x minus 2 over x all over x over x minus 3 over x. Now when I look at this, x over x becomes 1. 2 over a large number approaches 0, so I can put 0 in its place. X over x on the denominator approaches 1. 3 over x, 3 over a large number approaches 0. That's heading towards 1. So now I can see that my horizontal asymptote is the line y equals 1. But what I need to do is study what happens as x approaches infinity. What's actually happening? So as x approaches infinity, I'm putting a big positive number into my question. So y will approach, I'm going to use 999 minus 2 over 999 minus 3. What's that approaching? Put that into your calculator and you actually get 1.001, which means it's approaching 1, but it's a tiny bit bigger, so it's a 1 from above. As x approaches minus infinity, y is going to approach, let's pick a large number that's negative, minus 999, take 2, minus 999, take 3. Put that into the calculator and you'll get 0.999, so it's approaching 1, but it's a tiny little bit smaller than 1, so it's approaching 1 from underneath because it's a y value there. Now the next part says to find any vertical asymptotes. Vertical asymptotes come from looking at the denominator, setting it to 0. If x was 3, I'd have a problem because I'd get a 0 on the bottom of the fraction. 3 is not an answer on the top, which means x equals 3 is my vertical asymptote. Well, let's have a look to see what happens as x approaches 3 from the left and as x approaches 3 from the right. What happens? Okay, so if x was a number close to 3, but it's on the left of 3, think of a number line. To the left of 3 on the number line would be something like 2.999. So that's what I'm going to use. So my question now becomes 2.999 take 2 over 2.999 take 3. And if you put that into your calculator, you'll get minus 999, which means it's approaching a large negative number. If you put in 2.9999999, it'll be an even bigger negative number. Now I want to approach 3 from the right-hand side, a number a little bit bigger than 3. 3.001 is close to it. So I'm going to put in 3.001, take 2, on 3.001, take 3. If I put that into my calculator, I'll end up with 1001. And that means it's approaching a large positive number. Now it's time to sketch the curve. So let's sketch the curve. Now when I'm sketching the curve, do I have any asymptotes? Well, yes, I have a horizontal asymptote at 1 and a vertical asymptote at 3. So a horizontal asymptote is the line y equals 1. Vertical asymptote is the line x equals 3. What happens way out to the left here? So as x is approaching minus infinity, your graph is approaching 1 from underneath. That's what the minus means. So we're approaching 1 from underneath. What's happening as you're approaching your asymptote? Well, the asymptote is the vertical asymptote, that is at 3. If you're approaching the vertical asymptote from the left, you've got a y value that's large and negative. So it's heading minus infinity, which means, probably go through like that. I'll check for the x and y intercept in a moment. If I'm approaching the vertical asymptote from the right, my y value is really big. A y value that's big is up near infinity, and it'll go like that because as I approach plus infinity, my y value is approaching 1, but it's a little bit bigger than 1, so it's just above it. Now, how can I find the two intercepts? Well, to find an x-intercept, let y equal 0. If I came up here and let y equal 0, I get 0 equals x take 2 on x take 3. Multiply the x take 3 across to the other side. 0 times anything is 0. If I solve that, I get x equals 2. So I can come down here and say it crosses the x-axis at 2. How do you find where it crosses the y-axis? Let x equal 0. If that's 0 and 0, I get minus 2 on minus 3, which is plus 2/3. So there's the sketch of our curve. Let's go to number 3. Now this is just examine the horizontal asymptotes and the behaviours. So looking at part A, looking at the denominator, x squared is the denominator's highest power of x, so we're going to divide every term by x squared. If I divide every term by x squared, I get x over x squared plus 2 over x squared all over x squared over x squared minus 9 over x squared. And when I do that, well, x over x squared becomes 1 over x, and 1 over, remember x is a large number, positive or negative, 1 over x is approaching 0. 2 over x squared approaches 0. X squared over x squared approaches 1. 9 over x squared approaches 0, which means that's approaching 0. My horizontal asymptote is the line y equals 0 for part A. And we go as x approaches infinity, y approaches, well, I'm looking at the question, putting in a big number, so let's put in a big number. I might go for 999 plus 2 over 999 squared minus 9, and that is approaching, if I put that into the calculator, that's approaching 0.001. which means it's approaching a really small positive number. As x approaches negative infinity, y approaches, I'm going to put in a large negative number now. Make sure you use a bracket. And what do we actually generate? If we look at the calculator, negative 0.001 is what I ended up with, which means it's approaching a number very close to 0, but it is negative. So that's the behavior around my horizontal asymptote for part B. Let's go to for part A. Let's go to part B. In the denominator we've got an x, so we're going to divide everything by x. So let's do that. X squared over x minus 2 over x over x minus 5 over x. X squared over x cancels down to x. 2 over x gives 0, because anything divided by a large number is 0. X over x is 1, 5 over x will become a 0. That's heading towards y equals x, and that's actually the asymptote. But that's not a horizontal line. This question says, noting any horizontal asymptotes, and we don't do asymptotes that are not horizontal or vertical at the moment, so we're going to stop there and say there is no horizontal asymptote for this question. It's actually far more advanced. It's actually what they call an oblique asymptote. Let's go to part C. We're going to look at the denominator. The highest power of x is an x squared, so every term is going to be divided by x squared. So if I divide every term by x squared, I get 2 on x squared minus 3x on x squared minus 5x squared on x squared all over 5 on x squared minus 6x on x squared minus 2x squared on x squared. There are a few bits that are going to cancel out, so if I look at this I can see that x squareds cancel, the x squareds cancel. This part's going to become a 0 because anything over x is 0. Effectively that leaves me with minus 5 and minus 2. So it equals minus 5 over minus 2, which is just 5 over 2, or 2.5. As x approaches infinity, y is going to approach, need to put in a large number for x, I'll put in 999. And you can see that I'm rewriting the question. Wherever I see x, I'm just putting 999. When you put that into your calculator, you'll get an answer that is very close to 2.5, because that's a horizontal asymptote. The answer is actually 2.49, very close to that, which means it's approaching 2.5, but it's a tiny bit smaller, so it's a little bit underneath. As x approaches minus infinity, we do the exact same thing, except every x value is now a large negative number. Really important to use the brackets, especially for the parts that are squared. And when you put that into your calculator, you get positive 2.506, which is an answer that's close to 2.5, just a tiny bit bigger or above. And that's the process that we follow. Right, one more to do. This last one is a bit of a trickier one. Normally you look at the denominator and you would say divide by the highest power of x, but this is not written in the correct form to do that. This is written using an exponential. So what we're going to do is we're just going to say as x approaches infinity, y approaches, go for an approaches sign. Now I could put 3 to the power of 999, but that number is so big your calculator can't cope with it. Even 3 to the power of 99 is too big for your calculator to work with nicely. So I'm just going to try 3 to the power of 9, because that's still going to give me a large number. If I put 3 to the power of 9 in the calculator, that will actually give me an answer of 1.001, which is an answer that's just a tiny bit bigger than 1. If I put in a large negative number, again, don't make it too large because it's exponential. Your calculator can't cope with anything more than 100 digits long. Put that into my calculator and I'll get negative 1.001, which means it's approaching negative 1, but it's a little bit to the left of it. Now that's a little bit weird, but this question here is a weird graph. If you actually graph that, you actually have two horizontal asymptotes. To the right hand side, as you approach really large numbers of x, you have a horizontal asymptote of y equals 1, And on the left-hand side of the graph, as you're approaching large values of negative x, you have a horizontal asymptote of y equals -1. Right, time for you to try some questions. Enjoy the experience.